Hello everyone. Our next chapter is maxima and minima. From this chapter you will get one LAQ for 7 marks. In order to solve the LAQ you have to remember few points. So the first one is for any maxima or minima the function f dash of x is always equals to 0. And we have to differentiate the function twice. If its value is less than 0, which will be a negative function, then the function is maximum. And if the function differentiated twice is positive, it will be greater than 0 and the function is minimum at x equals to a. So our first problem is, if curved surface of right circular cylinder inscribed in a sphere of radius r is maximum, show that the height of the cylinder is root2r. So the curved surface of a cylinder, this is a cylinder which is inscribed in a circle, and the sphere is having the radius as small r, and this will be the center of the circle. We'll take it as O, and we'll consider, let capital R be the radius and h be the height of a cylinder. So we'll take a capital R as, we'll draw a line like this, so it will be a right angular triangle. I'll mark it as A and B. So the radius of a cylinder is taken as capital R and the height is considered as h. Complete it is considered as h, so the half will become h by 2. Okay, and given is small r is the radius of a sphere. Now in triangle OAB, we'll write the Pythagoras theorem. So the opposite side square is OA square plus adjacent is AB square is equals to the hypotenuse OB square. Substitute the value of OA, which is equals to h by 2 square, plus AB is capital R square is equals to small r square. So this will become h square by 2 squares is 4 plus r square is equals to small r square. From here we'll get the value of capital R square is equals to small r square. This comes over there, so it will be minus h square by 4. Take it as equation 1. Now it is given that the curved surface area of a cylinder, right, is maximum. So we have to write the formula of curved surface area of cylinder. S is equals to 2 pi RH. Now we are having the value of r square, right? So we have to square this equation on both sides. So we'll get s square is equals to 2 squares is 4 pi square capital R square h square. Substitute the value of r square in this equation. So from 1 we get s square is equals to 4 pi square into r square minus h square by 4 into h square. Now we'll multiply this h square inside with both the terms. So we'll get s square is equals to 4 pi square into h square r square minus h square into h square is h power 4 by 4. Now multiplying the 4 pi square inside with the two terms, so it will be 4 pi square h square r square minus 4 pi square h power 4 by 4. 4 gets cancelled out, so it is s square is equals to 4 pi square h square r square minus pi square h power 4. Now this is our function f of h. Okay, we have to show the height, so we'll differentiate with respect to h. So let f of h is equals to our function 4 pi square h square r square minus pi square h power 4. Differentiating this function with respect to h, so it will be here 4 pi square r square is considered as constant. H square derivative will be 2h by using the formula x power n derivative. Okay, here also pi square is constant as it is. H power 4 derivative will be 4h cube. Now differentiate it again. F double dash of h will be equal to 4 pi square r square. 2 into h derivative is 1 minus pi square into 4 into h cube derivative will be 3 into h square. So this can be written as 4 2s are 8, 8 pi square r square minus 4 3s are 12, 12 pi square h square, which is nothing but f double dash of h. Now we know that for any maxima or minimum, the function f dash of h will be equals to 0. So we'll equate f dash of h is equals to 0. So we can write this function as 4 to the 8, 8 h square r square h minus 4 h pi square h cube. This is the value of f dash of h. We'll substitute in an equation and equate to 0. So it is pi 8 pi square r square h minus 4 pi square h cube equals to 0. Taking 4 pi square h common, so we'll get 2 r square minus h square equals to 0. This goes there, so it is 0 pi and it is 0. So we'll be left with 2 r square minus h square equals to 0. This can be written as, taking h square there, so it is positive. H square is equals to 2r square. Square goes there, so it becomes root. So it is h is equals to root 2r square. For r square and root get cancelled, so we'll get h is equals to root 2r. So we know that if f double dash of x is less than 0, the function f of x is maximum. So substitute h is equals to root 2r in f double dash of h. So f double dash of h will be equals to 8 pi square r square minus 12 pi square h square, which is equals to 8 pi square r square minus 12 pi square. Substitute the value of h here, so it will be root 2r square. For 2 the square and root gets cancelled, so it is 8 pi square r square minus 12 pi square into 2r square. So it is equal to 8 pi square r square minus 12 2s are 24 pi square r square. So this can be subtracted. 24 minus 8 is 16. Negative is the bigger sign. So it is minus 16 pi square r square, which is negative. So it is less than 0. Therefore, we can say that f of h has maximum value at h is equals to root 2r, and the curved surface area of cylinder is maximum at h is equals to root 2r.